All right, ladies and gentlemen, there's no time to waste. We've already been off for another week. So, as again, this is Resh Mahaber, and I just want to continue where we left off. Right before we left off from break, we started talking about section 8.5, which were quadratic-like equations. Okay, so before we get into it, I'm going to be jotting down some notes here for you guys that I think are valuable. I would advise you guys to take notes as well. And I'll have you try a couple problems along the way too, okay? So here we go. Take it really, really easy. But it all starts with the knowledge we should have had before we started the section. So if we could do these problems, which is the review stuff, then we can do the stuff that's later. So here we go. So let's say I were to ask you this. This is the review stuff. I just said solve, okay? And the guy I want to solve is this beautiful creature. Is 2x squared minus 3x plus 1, and that thing equals 0. Okay, so if I ask you to solve this guy, obviously most of you guys already have a good instinct and you're saying, oh, factor it. Well, what told you that you should probably factor this? Well, you saw some stuff happen with it. You saw that there's something squared and there's a regular old x here. So parts of you says, oh, guess and check. And if I can't guess and check and solve this guy, don't forget, because it's a quadratic, a degree 2, we have the ability to use we have the ability to use quadratic formula and solve this guy. All right. So, but the instincts are still the same. So it's quadratic, which means that it's something squared plus something and plus 1, right? So we already know that once we do a little bit of guess and check, we'll say this, right? And then we'll say minus 1, and then 0. And then you guys would solve this like normal. And this is what is standard at this point. So you guys should already know how to solve this stuff. So I'm not going to go into detail here, okay? So but the big point is this. If it was a quadratic, a degree 2, then I can use everything I know about the equation I'm trying to solve. That's degree 2. Okay, so welcome to section 8.5, and section 8.5 is not about degree 2s. It's about all the degrees that we really do not deal with too often. Okay, so here we go. So we get down on my desk here. So section 8.5 is about solving things that look quadratic-like. Okay, and what I mean by looks like quadratic-like, I'll show a couple examples, but quadratic-like equations. Okay, now what are those? All right, so some of you guys remember this from before we left for break, and some of you guys have probably seen this for the first time, depending on where we left off with this whole coronavirus thing. Okay, so recall there are only two ways we know how to solve things. Okay, that's factoring. Okay, that's the first one, and the second one is factoring a quadratic formula if they're a degree 2. Okay, well, check this out. Okay, let's say we had a guy that looked like this person. Okay, x to the 4th minus 5x squared plus 4 equals 0. Now, is he degree 2? Well, all of you probably have said no. What degree is he? He's degree 4. Okay, so quadratic formula would not work on this. We don't have no another factor, so we can't use like that division stuff we learned in section 6.6. So what are we going to do in order to solve this guy? Well, it just so happens this guy is a very special polynomial. What I mean by special is he follows a certain formatting. Okay, so recall this. Let's go back in time. You guys all remember this one. It was a thing out of section 1.6. It was that if I have a exponent raised to an exponent, then I can multiply the two. And I'm sure we all remember that. Well, remember, an equation doesn't just work one way. It works two ways. And what that means is that this thing here, the a to the m times n, is the same as this guy, which gives me permission then to write things such as x to the 4th as things like x to the 2nd squared. And why? Because 2 to the 2nd, x to the 2nd squared, exponent to an exponent, I can multiply that too. So it gives me that ability to do that. Okay? So when we say solve stuff like this, okay, you have to recognize patterns. Now, before we go any further, and I'm trying to keep these videos relatively small, so I'm going to try to talk about topics very quickly and go through 2 or 3 examples, okay, guys? So if they run a little longer, feel free to speed past the example if you kind of already get the drift of things, okay? So what makes a quadratic, okay? It isn't so if we look at 2x squared minus 3x plus 1 equals 0. What made this thing a quadratic wasn't the numbers. It was the fact that this was a degree 2 and that was a degree 1, okay? But x can stand for anything, okay? So check this out. So that means practically a quadratic, the way I really need to view it is this is 2 times something squared and 3 times that same something. And it could be anything, okay? It could be x, it could be y, it could be z, right? Or it could be something else that's more elaborate. So check this out, okay? So if you look at this guy, x to the fourth, well, these two guys have a relationship, okay? And this is why I was saying in class before we left out for break that this section takes a little bit more number sense, more intuition. It's not just plug and play, okay? So you have to think a little bit more. Okay, so you're trying to say to yourself, and I'm going to write this question down on the screen because it's an important question, which one, and what are the two you have to choose from? X squared, this guy in green, and x to the fourth, or, I don't want to say and, I want to say or x to the fourth, okay, is the square of the other. This is the key question. If I had a key, I would put it on the screen right now, okay? So, which one of them is the square of the other? Okay, so check this out. So this is my thought process behind this. This means that if I were to square x to the fourth, okay, if I were to square x to the fourth, does that give me the other one? What's the other one? The other one is x squared. Of course not. That makes no sense. It gives you x to the 8th. That's terrible. But check this out. If you square x squared, does that give you x to the fourth? Which is the other one? Absolutely. Okay? So if that happens, then what you're telling yourself is that these two guys have a relationship, him and him. So all of this work, this question that I told you to ask yourself, it's a very important question, but it all should be done in your head. Okay? So you're asking yourself this. Because not everything is quadratic-like or quadratic-ish. Some things are much more than quadratic-like. Okay? So check this out. Well, that means I could rewrite this. That means that I could rewrite x to the fourth as x squared minus that same x squared that's here. Now, isn't that interesting? And what I mean by isn't it interesting, okay, guys, not to make it like a professor talking to a bunch of students or anything like that, okay, but to make it interesting, check this out. So it's still something squared, something, right? So it's quadratic-like, but it's not exactly the same. So here's the point, okay? In mathematics, whoops, I got the big thumbs and fingers and all those things. Sorry, guys. In mathematics, here's a good thing. Patterns are key, okay? And sometimes we call this reparameterizing an equation. Fancy word, okay? But we call it reparameterizing or establishing a dummy variable. So what we'll do to make this easier, because it's so hard to look at this in the way that it is, I'll say let. Now, the dummy variable we tend to use, there's actually two letters we tend to use throughout mathematics, and that's U and V, all right? But U is the guy we're going to use here. I'm going to say let U equal the thing that's appearing everywhere. And then what's the thing that's appearing everywhere? Well, x squared. Okay, so let's let U equal x squared. So effectively, what this equation here, right here, is going to become is, it's going to become, well, get rid of that. Whoops, I erased too much. It'll become, whoops. Sorry, guys, my tech is all, the whole system seems to be running slower today because of the whole corona thing, because everyone's online right now. So, anyhow. So this is like saying u squared times u. And now, this is a guy we've seen before. This guy's very, I'm going to make it a little cuter. This guy's someone we've solved before. We can solve this. We can factor it. Okay, so it's in quadratic form. That's the point. It's there. It's just very special that you could write it as something squared and something else. Okay, so in this case, it was x squared, and x squared. Okay, so when you chose your u, it was because you were substituting this out for u and that out for u. Now, we're just going to solve like normal. So check this out, okay? Does this factor? Yes, it does. Thank goodness, because if it didn't factor, then guys, it is going to suck terribly, because whose formula do I know that I can use now? That's right, quadratic formula. Oh boy. So u minus 4 equals 0, u minus 1 equals 0. Effectively, u is 4 and u is 1. But hold on. Are we done? As all of you have already said, no, we're not done, Resh. Why are we not done? Because we're not solving for u. We are solving for x. We started the problem with x's. We must end the problem with x's. All right, so here we go. If we have to end the problem with x's, well, how do we get back to x's? Well, didn't you just tell me that u equals x squared? So we used u to help see it better so we could factor it or use quadratic on it or to see if it's even quadratic-like. And then we took the u and we're going to change it back into x's. So anywhere I see a u, let's change it back. So u is now going to turn into an x squared. And that effectively means if u turns into x squared, this equals this, and this equals this. Now, all we got to do is solve those two guys. And if I don't know which version you guys do, whether you guys are used to subtracting the 4 over and then factoring out the difference of squares, but I'm sure Matt and I have both showed this, so I'm going to do this. When we square root an equation, this is perfect. Whatever you do to one side, you're going to do to the other side. Why? You want to undo whatever's exponent is there. So this is going to give me regular old x on the left side. This gives me regular old x, but what's the answer you should get? Okay, don't forget that when you square root a number, immediately you're going to have the positive version and the negative version. Why? Because when you square either one of those, the positive or negative will go away. Okay, so that's why it's always going to be plus or minus. Quick version, quick explanation. And likewise, this one's going to be square root of 1 plus or minus that, which gives me plus or minus 1. Okay, so my 4 answers, and yes, you must check them. These just happen to work because this is a very clean polynomial, okay? But make sure you check your answers. Big point, okay? So, your answer are plus or minus 2 and plus or minus 1. All right, done and done. All right, so very simple. So let's go over it one more time. Okay, you see a problem that looks weird, higher than degree 2. You're not used to solving anything higher than degree 2. What do? Okay, first things first, you say to yourself, okay, is it quadratic-like? And if it's quadratic-like, that one guy, one of those variable pieces of the pie, okay, and you got to look for patterns here. It's not always just a variable, okay, because sometimes it could be an equation or a bubble, an absolute value maybe, okay, so look for patterns, okay. Which guy is the square of the other guy? Okay, so this one, it was clear that x to the 4th is definitely x squared squared. That was the breaking point. Once we use that, boom, change all of our x squareds into u's. So this guy turns into a u, so does him. And then it's a normal problem from chapter 5. Let's factor it, let's solve it, or quadratic formula of it. Okay, finally, plug your x's back in and then solve those equations. So we basically found a backdoor way in to solving a much harder equation because we're using already the information that we already know. Okay, plain and simple. All right, let's do a couple more examples because they're not always this easy. So what was the part that made this problem easy? Was this. It's always the starting points. It was recognizing that this guy is a square of the other guy. So it really pivots this problem. These types of problems really pivot on the idea that you can rewrite it as something else squared. Okay, and there are different instructors, they teach it differently. So some of them will say, well, who is u? Then if you square it, the check is the other one, right? So I'll show you an example and I'll talk through that one as well. Because I think Matt teaches it that way as well. Okay, for you guys who know Matt. Half of you guys know Matt. All right, so here we go. All right, rock and roll, people. All right, here's a good one. Try this one on for size. This one's kind of the same as the last one. Yeah, this one's kind of the same as the last one. But let's do it. Example. Okay, it's solve. Okay, and no one gives you a hint that you need to use quadratic formula or you do need to factor or you need to do anything. Okay, it just says solve. So you got to use your wits about you. What gives me a good indicator that this guy is going to be a trickier guy is because he's not degree 2 or not degree 1. He's this guy that looks very degree 6, which we don't have enough firepower for that yet. Not in a real bulldog kind of a way. That's pre-calculus. That'll give you that. All right. So you look at this, you're like, oh my goodness. Well, hold on. I'm seeing patterns here. Okay. So here's my brain. Boom, boom, boom. And for my guys, they know I normally say, here's your brain on drugs. I realize something. I realize that this guy and this guy, that little pattern that I'm seeing here. And what is the pattern that I see? Let's go back to my brain. I'll show you what I'm seeing. I'm seeing that x cubed to the second power, or squared, is going to end up giving me x to the sixth. Okay? And then why am I so happy about this? Because I know that x to the sixth, I could rewrite it as this guy on the left, and this guy on the left has the guy in the middle in it, right? So effectively, this is what I'm going to do. So check it out, check it out, check it out. I'm going to rewrite this as x cubed squared, right? And then I'm just copying everything else down the way it is. Okay, I'm going to copy everything else down the way it is. Okay, just want to bring some highlights to that. Now you'll see it, right? That this x cubed is the same as that x cubed, but this one's being squared. So it lets me know my u has for sure got to be x cubed. So really it pivots on your ability to recognize patterns, okay? I will go, so, and I'm going to do the other way that some people have seen. I don't know if some people, actually no, this is okay. This is okay. So now this turns into u and u squared minus 3u plus 2 gives me 0. Okay, guys, I just got sick of changing colors, but I changed this into u. I changed that into u. So now it gives me u squared minus 3u plus 2. Can we solve that? Hopefully. All right, so let's solve it. So we get u minus 2, u minus 1 equals 0. Let's solve. So we get u equals 2, u equals 1. Again, we're not solving for u, we're solving for x. So let's do one with, so let's substitute our x's back in. Okay, and in order to do something that is cubed, what do we need to do? And yes, we should already know right now that roots undo exponents, so I'm going to cube root both sides of these equations. And remember, only square roots have plus or minus, not cubes. So this is going to be the cube root of 2, and x equals the cube root of 1, which is just 1. So it's just those guys. Okay, and if you plug them in again, you'll see that they check. Now, must you check everything? Absolutely, because everything doesn't check out, unfortunately. Okay, so crucial, crucial, crucial. Okay, moving on. Okay, video right now is about 17 minutes, so I want to make sure that we don't run much longer than 20 minutes. Okay, so I'm going to choose my next example a little wisely here. Okay, so here's another one. Okay, again, we're looking for quadratic-ish stuff, and it looks very weird. So here's the weird one. Put this guy in green because it's money. This one came from the final exam of 2018. I forget if it was fall or winter. Okay, it was x to the 2/3 minus 3x to the 1/2 plus 2 equals 0. Sorry, 1/3, not 1/2. Okay, now the question comes out to, oh my goodness, well, what do I do? All right, no big deal. You think about it. Think about your laws of exponents. Which one of these is the other one squared? All right, so start thinking to yourself. Okay, you got two options here. Who do I square? Who can I square to get the other one? Okay, so you got two options. You got this guy and you got this guy. So your instincts already says, okay, well, let's say your instincts aren't playing a good role. Let's say you don't know which one to choose. Okay, so you say, okay, well, what if the u was going to be x to the 2/3, the guy in the front, okay? Well, that means if I squared this guy, it should give me the other guy, right? But if I squared this guy, it gives me x to the, well, what do I do when I have an exponent to an exponent? I have to multiply the two. Don't forget, this is 2/1, so this is going to be like 4/3. Well, is 4/3 over here anywhere? No, okay? No. So therefore, u cannot be x to the 2/3. Bad u, okay? Or, so now let's try the other one, okay? If you were to square x to the 1/3, that for sure would give me x to the 2/3. So bingo. Bingo. So what does this tell me? X to the 2/3 can be rewritten as that. So literally, I'm just going to write x to the 2/3 as the other one, okay? So we're trying to see which guy is the square of the previous. Okay, now it becomes very clear where our u is going to be. U is going to be this beautiful blob, which is x to the 2/3. Done and done. So that means effectively, And this is what we always try to go for, is to show you how you should be operating. This is going to be u. That's going to be u. I'm going to change those green squared minus 3 plus 2. I literally just changed them into u, so I'm letting u equal x to the 1/3, right? Because that's what the guys that are the same. So that's this. And now it's just a matter of factoring this and running through it like it did. Now this is the exact same problem as before, if you guys noticed. So this is no different than the last problem we just did. If you guys want to run back and look at it. The exact same u problem. So my point is that you can, the same polynomial, the quadratic-ish kind of like format, can be inside of any problem. It looks the exact same way, except the u is changing. Okay, the dummy variable is changing. Okay, so you always got to play with it and make sure you establish the correct u, choosing u correctly. All right, so you get u squared. All right, so now you just got to solve, which is the same thing. Solve. I'm not going to waste time doing this. I'm just going to go back to the fact that when you use the previous work, you get u is 2 and u is 1. So u equals 2, u equals 1. Once you go through and solve, you can go through and do the work again on your own too. Don't ever feel like you have to trust my work. I would always support you to write it down and then to go through it yourself. Okay? And then, well, what was u again? Well, that's why it's so important you make u clear that you wrote down what u is going to stand for. So now when we plug it back in, you get x to the 1/3 equals 2. X to the 1/3 equals 1. But hold on a second here. How do we undo exponents, right? Well, if it was an exponent, we would root it, right? Well, I want you to think about this. When we solve for something, we want x equals a number. Okay, now I don't know what this number is. Okay, I don't know what it's doing. Okay, but bottom line is, this is x to what power? This should be a 1 right here. Okay, so I want you to think about this. What can I raise both sides to undo those exponents? Now, I want you to think about this, because you already know an exponent to an exponent to an exponent, you multiply the two, right? And if I can multiply that by something that gives me back 1, well, now I'm cooking. So here we go. What can I raise it to? Well, here we go. It's a 1/3. I know when I'm multiplying fractions, I multiply straight across. So that's 3. I'm going to raise it to 3 over 1, because that's the definition of the reciprocal. So I'm going to raise it to 3. Okay? So I'm going to cube both sides. When I do that, oh, well, that lets me know that this is going to be 1, which is just regular old x. Great. And that's going to be equal to 8. So what's the moral of the story? Raise it to the reciprocal is a big piece of the puzzle. So your answers 8 and 1. Again, do not forget to plug them in and check them, because sometimes they will not work. Okay, so check it out. We'll check 2 just so you guys can see. If I plug in, 8. If I plug in 8 to the 2/3. Well, 8 to the 2/3 thus means I'm going to take the cube root of 8 and then square that. 2 squared, which is 4. Okay, so this is 4. Okay, so that's a 4. And then I'm going to do 8 to the 1/3, which is the cube root of 8, which is just 2. So that's just scrap paper. All right, so this is going to give me -6. So 4 minus 6 is -2, plus 2 gives me 0. Check. So it should check every single time. And of course, better your number sense, the easier they'll get. The easier they'll get. Okay, all right, so that's 1. Okay, so moral of the story, if you ever run into a situation where you have, and this is a great tip, okay, for anything, and you have a fractional exponent, so Resh will always give you cool tips, and this is a big one. So if you have a fractional exponent, so if you had something like x to the 2/3, 2/3 equals, say, 16 is too big. Let's try 9. All right. All you got to do to undo that exponent is raise both sides to the reciprocal, which is 3 over 2. And why is that easier? Because if you raise it to the reciprocal, then this ends up being x to the 6 over 6, because an exponent to an exponent, we multiply the two. And since they're fractions, I multiply the numerators and the denominators. Okay? And this ends up giving me just regular old x. Yay! But this thing will give me the square root of 9 cubed, which is going to be 3 cubed, which is 27. Okay, so moral of the story is, if you want to do a fractional exponent, multiply by the reciprocal. Not multiply, but raise it to the reciprocal, because then those fractions, the numerators will multiply by the numerators, the denominators multiply by the denominators, everything will work itself out. All right, so that's it. So, and I can't go through every kind of problem that's here, because there's just entirely too many, because how many different ways, I've used the same quadratic for many of these, right, the formatting, but it's made you different things, and the problems look totally different, okay? So you got to go through, you have to look for the thought process, which is, which one of these is the square of the other? If you could figure that out, then you'll know which one to make your u. You factor it, you change them back into your x's, and then you solve. Okay? Really, really simple. All right, guys. I think that's it for section 8.5. All right? Next time, we will talk about graphing. Okay? Graphing exponents. Graphing exponents is always, not graphing exponents, graphing quadratics. This is where things are a little tricky, okay? So be very, 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 very careful. Alrighty. Don't forget, office hours are going to be held online, okay? Make sure you look for mine and Matt's, okay? But I really want to make sure you guys are getting everything you need to get, and that you feel like you guys can reach us at any point in time, okay? Not any time in the day, but like we're not far away. If anything, we're really close, because all you got to do is hit a button now. All right? So don't forget to go to office hours and ask good questions. All right, team. Remember, if you want to go someplace you've never been, you're going to have to do some things you've never done, all right? So keep working hard, keep pushing yourself to failure, and every time that you fail, the next time you'll take more and more and more, and you'll be much, much better. All right, team. Signing off. Bye-bye.